All right, so today we're looking at section 1-2, that's chapter 1, the second section, and it's called Measuring and Constructing Segments. So the first thing we're going to talk about is something called the Ruler Postulate. So yesterday we talked about this word postulate, and it means it's a statement that we know is true, okay? So how many of you have seen a ruler before? Only one person? All right, awesome. So basically, we've got this ruler, and there's a postulate about it. So go ahead and draw a fake little ruler on your paper, like this. And there's going to be some 1/8 inch marks. There's a 1/2 inch mark. And then there's a 1 inch. So it kind of looks a little bit like this. So what this ruler postulate says is something like all the points have a 1-to-1 correspondence. That just means that if something lines up and measures from the 0 to the 1, it's going to be 1 inch. That's all. It's like this obvious true statement. Okay? And for geometry, we need to talk about this thing called distance. And the main thing that you need to know about distance in geometry is that it's always going to be positive. Okay, so whatever answer you get, you're going to take the absolute value of the difference. So we're going to put little absolute value bars, kind of look like little sticks. So you're going to find the difference between the two numbers. So let's say you put your ruler down and you're measuring something, and it measures from the 4 to the 5. Okay? Because you didn't set your ruler the right way, but you start at the 4, you end at the 5. So you're going to go 4 minus 7, which gets you -3. So would you say that it's -3 inches? No, you would always say it's +3 inches. That's why we put the absolute value bars. You're always going to have a positive number. Oh, wrong way. So the distance is always between your 2 points. You start at 0, great. If you don't start at 0, you just subtract and then take the absolute value. All right, let's look at an example. We'll call this example number 1. We're going to draw a number line similar to the one above my whiteboard over there. And we're going to add some numbers to it. Going to the right, those are positive numbers. Going to the left, those are our negative numbers. And I'm going to put a couple points on here. A is going to be at -2. B is going to be at +1. And C is going to be at 3. Okay. So we're going to find each length. Sometimes they'll use the word length. Sometimes they'll use the word distance. They both mean the same thing. The first one we're going to find is BC. So for BC, we're going to put our absolute value bars because whatever number we get, we want to make sure it's positive. We're going to find the location of B. It's at 1. We're going to subtract the location of C. It's at 3. So 1 minus 3 is -2, but we need to put the absolute value bars around it. So the answer is what? 2 positive, right? Do you have to write the plus sign? No. All right, let's find the distance from A to C. So A is at -2, and we're going to say minus C, which is at 3, and then we're going to put some absolute value bars around it because we want our answer to always come out positive. So -2 minus 3 more gets us to where? -5. So we're going to take the absolute value of -5. which means the distance from A to C is 5. Okay? The next thing we're going to talk about is this word congruent. Oh, I spelled it wrong. Congruent segments. And as geometry goes along, we're not only going to have congruent segments, we're going to have congruent triangles, we're going to have congruent quadrilaterals, we're going to have congruent pentagons. This word is going to keep coming up in geometry. It basically just means the same size and the same shape. Okay? So right now, we're going to make 2 segments. We'll call the first one PQ, put a little bar over it. And then we're going to use this new symbol that you're going to learn about today. You start with the regular equal sign, which hopefully you guys have seen an equal sign before. The only thing different is you add this little squiggly line over the top of it. That's the symbol for congruent. We're going to say that segment PQ is congruent to segment RS. And as long as your 2 segments have the same length and the same shape, they're going to be what we call congruent. So here's segment PQ, and I'm going to turn the other one, but I'm going to make it the same length from R to S. And this statement says that PQ is congruent to RS. Now, once we say that they're congruent, we're going to add something to each of those segments. It's called tick marks, T-I-C, tick marks. So the tick mark looks like this. You just put a little slash and a little slash. They're called tick marks, and they are just basically representing that those 2 segments are congruent to each other. I'm going to move this up. You'll see it in just a second. If you're still writing, you'll see it. There it is. All right, so we have the ruler postulate. Now we're going to talk about the segment addition postulate. So the segment addition postulate does exactly what it sounds like. You're going to have a segment, and then you're going to add another segment, and you're going to put them together, okay? Start with a segment, another segment, addition. Addition just means add. So if I draw a segment right here, we'll label this A and B, and then I add another segment right next to it, we'll call it BC. The segment addition postulate basically says this, that the first piece, which we'll call segment AB, plus the second segment, which we'll call segment BC, guess what it equals? Segment AC. It equals the whole thing, right? So the 2 small pieces added together equal the whole thing. Okay? So whatever first piece you add plus the second piece, put them together, the segment addition postulate, you just add them. Okay, which leads us to example number 2. Guess what we're going to add? 2 segments, okay? So we're going to say that segment FG is 6 inches and FH is 11 inches. G is going to be between F and H. I meant to say F and H. So if G is in between them, when we draw it, we're going to put G in the middle somewhere. And if F to G, we'll put right here. Here's F. F to G, we said, is 6 inches. And F to H, the whole thing, so let's make this H. The whole thing is going to be 11 inches. Okay, so we're going to use the segment addition postulate, but we're not actually going to use addition. What are we going to use? Subtraction. Okay, even though it's called the addition postulate, we actually have to figure out what number is being added. So that's actually subtraction. So we'll put a little x right here. And we'll say that these two added together, so 6 plus x, is going to be equal to the whole thing, 11. Subtract 6 from both sides. So that little piece right there is how many inches? 5. All right. Example number 3 is really similar. But instead of just using numbers, we're going to use some algebra. That's why we did the Algebra 1 review before we started the book, right? So we're going to have a segment from N to M. And then we're going to have another segment from M to O. And I'm going to give you some measurements. From N to M is 17. From M to O is 3x minus 5. And from N to O, so all the way from here to here, is 5x plus 2. All right, so we're going to use that segment addition postulate. We know that the first piece plus the second piece equals the whole thing. So we're just going to set up the algebraic equation. We're going to say 17 plus 3x minus 5 is equal to the whole thing, 5x plus 2. Okay, so this is combining a geometric concept with an algebraic concept. Okay, so you got to pull out of your brain your algebra, right? So let's combine these like terms. We have a 17 minus 5, which is what? 12. So 3x minus 12, plus 12 on the left, and 5x plus 2 on the right. I prefer my variable on the left, so I'm going to subtract 5x from both sides, but you could just as easily subtract the 3x if you don't mind it on the right. In the same step, I'm going to subtract 12 from both sides. 3x minus 5x is negative 2x. These are opposites, they cancel. These are opposites, they cancel. And 2 minus 12 is negative 10. And now it's not so bad. I'm just going to divide a negative by a negative to get my positive. X equals what? 5. Now, once in a while, you'll get a negative answer here. And you'll go, wait, I can't have a measurement that's negative. Sometimes it's okay to just get x equal to a negative number as long as when you plug it back in, it ends up being positive. Okay? If you plug it back in and your final answer is still negative, you probably did something wrong. And that final measurement should be positive. All right. One more thing to talk about, and that would be the midpoint. Midpoint is made up of two words put together, mid and point. What do you think the mid stands for? Middle, right? So it's the middle point. And if it's exactly in the middle, then it's going to divide the segment into two equal parts. Okay. So for example number 4, if S is the midpoint of RT, then we're going to need to solve, right? So I'm going to give you that RS is equal to negative 2x. Let me move that up. There we go.